Hello students, welcome to Brilliant Qatar. D and F block elements 100 MCQ. Let's discuss in this session. Those who are seriously preparing for the upcoming 2025 chemistry board exam, please be here. Let us discuss the most important 100 MCQ in which let's discuss the entire theory of the chapter D and F block elements. You know, it's one of the inorganic chapter. Mostly they ask you reasoning questions from this one. Ready? So question number 1, let us start from the 2024, the previous year board question from D and F block is here for you. The correct order of the increasing oxidizing power of the 3D series of transition element is. See all, increasing order of oxidizing power. Dear, oxidizing power, if they ask you, check the oxidation state first. What is that? Oxidation state of that central metal atom we have to identify. Higher the oxidation state, higher the oxidizing power. So MnO4 minus, let me calculate Mn, what is the oxidation state? Mn we don't know directly, let me take it as X. One oxygen charge we know -2, so 4 oxygen charge is -8 and overall charge is -1, X equal to what? +7. So in MnO4 minus, what is Mn charge? +7. Next, Cr2O7 2 minus, let us check it. What is the charge of 1 chromium? So 2 chromium is there, therefore 2x. 1 oxygen -2, so 7 oxygen -14 and overall charge is -2. So 2x equal to 12 and x equal to what? +6. Here chromium is in +6. What about vanadium in VO2 plus? Vanadium X and 1 oxygen -2, so 2 oxygen -4 and overall charge is +1. So x equal to what? +3. Greater the oxidation state, greater the oxidizing power. So which one having greatest oxidation state, my dear? This one. So this is the highest and this is the same order. That is MnO4 minus having the greatest. Okay, MnO4 minus having the greatest. Then Cr2O7 2 minus least one. So option C. This is the 2024 board question they were asked. Ready? I think the question is clear. Let us go for second question. Which of the following has magnetic moment value 5.9? What is the equation for magnetic moment? Nu equal to root of n into n plus 2 Bohr magneton. Yes or no? Where what is n? N is the number of unpaired electron. N is the number of unpaired electron here. So if you want to get overall magnetic moment 5.9, if you want to get overall 5.9, what should be the value of n? N should be 5. So 5 into 5 plus 2, what is equal to? Root 35. You know, root 36, that's 6. Root 35 is what? 5.9. Near 5.9. So root 35 if you want to get, or 5.9 if you want to get, how many unpaired electrons should be there? 5 unpaired electron. Check it all where you have 5 unpaired electron. You know, Fe atomic number is what? 26. Fe atomic number 26, right? So what is the configuration we have? Argon and 4s2 3d6, right? Argon is 18. Next 2 electron in 4s, remaining electron in 3d. Fe2 plus means what? Fe2 plus means these two gone. So what is 3d6, right? What do you mean by 3d6? 6 electron. 1, 2, 3, 4, 5, 6. Here there is only 4 unpaired electron. We need 5. So answer is which one? Fe3 plus. Because Fe3 plus mean 2 electron go from here, 1 electron go from here. What it will be? 3d5. What do you mean by 3d5? Yes, there will be 1, 2, 3, 4, 5 unpaired electron. So if the system having 5 unpaired electron, what is the magnetic moment? Root of 5 into 5 plus 2, root 5 into 7, root 35, that's equal to 5.9. Ready? So answer is option B. Question number 3, anomalous electronic configuration is in 3D series. What is 3D series? Remember, mostly they ask you question based on 3D series. What are 3D series element? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. They are 3D series compulsory to know. All right. So in 3D series, we studied where is the special anomalous configuration, that is chromium and copper, right? Chromium and copper, because chromium is half field stabilized and copper is fully field stabilized. Yes, right? Question number 4. Which of the following D-block elements are D-block element? They are D-block element but not transition element. If it want to be transition element, what is the condition? If it want to be a transition element, that should contain incompletely filled d orbital either in their ground state or in their oxidation state. You know the set of element zinc, cadmium and mercury. Yes dear, zinc, cadmium and mercury, they are in the same group. They are in the same group. And zinc atomic number 30. What is the configuration? You will get 4s2 3d10. And cadmium, that is 5s2 4d10. And mercury 6s2 5d10, like that. So see, their d orbital is what? Fully filled. D orbital is fully filled. D orbital is fully filled in their ground state or in oxidation state. What is their oxidation state? 2+. If you take it 2+, this will go and remain also. D orbital is fully filled. If D orbital is fully filled, that what we can call, they are not considered as transition element. So zinc, cadmium, mercury, they are in D block, but they are not transition element. Ready? Next one. Transition element form alloys. What do you mean by alloys? It's a mixture of what? Two or more metal or metal and non-metal, right? So transition element form alloy easily because it's a question for exam. Why transition elements form alloys? Dear, the answer is they have nearly same atomic size. Because they have same atomic size, one metal can replace by another, so they can form a homogeneous mixture. So due to the similar size, they form what? Alloys. Ready? Question 6. Which of the following characteristics of the transition metal is associated with a higher catalytic activity? You know, transition metal used as catalyst because the main two reasons are there. Because they shows variable oxidation state and they provide large surface area. So what is the answer? They show variable oxidation state. Therefore, they shows catalytic activity. Which of the following has the maximum number of unpaired electron? Maximum. Let's see manganese. What is manganese atomic number? Manganese atomic number is 25. So we can write it as argon 4s2 3d5. Ready? What do you mean by Mn2+? 2+ mean 2 electron loss. What is left? 3d5. 3d5 means how many unpaired electrons here? There will be 1, 2, 3, 4, 5. 5 unpaired electrons will be there. Alright, so titanium, check it. Titanium atomic number is 22. Scandium, titanium, right? 22, how we write? Argon 4s2 3d2. And if titanium 3+ mean 3 electron lose. 2 from here, 1 from here. Only 1 unpaired electron here. You can check it, the other element. Vanadium atomic number 23, iron atomic number 26, you can cross check it. The maximum unpaired electron you can see 5, that is in Mn2+. Fe2+, I think we already discussed that also, right? Yes, there is 4 unpaired electron. So Mn2+ is the one having among this one highest number of unpaired electron. Question number 8, the property which is not a characteristics of transition metal, not a property. Variable, yes, they shows variable oxidation state, tendency to form complexes, yes, formation of colored complexes due to DD transition, yes, non-metallic, no transition elements, right? They are metal, they are metallic in nature, they are not non-metallic. Now, lanthanide contraction is caused by an increase in, what is lanthanide contraction? It is a steady but slow decrease in atomic size along the lanthanide series with increase in atomic number due to increase in effective nuclear charge. So, lanthanide contraction is caused because of what? Effective nuclear charge, due to effective nuclear charge. Now, which group of elements do transition elements belong? Simple question. Which all are our transition elements belongs? D block element, right? Transition elements belongs to D block elements. Question 11. Which of the following is diamagnetic? Diamagnetic means what? No unpaired electron. No unpaired electron. Let us see. Cobalt atomic number. So I think let us go for the direct answer here. We already discussed that. Zinc. Because Zn atomic number is what? 30. 30 means what is the configuration? Argon 4s2 3d10. Here Zn 2 plus, right? 2 plus means this 2 electron goes. What is left? D10. D10 mean what? Fully filled. There is no unpaired electron. So no unpaired electron or diamagnetic means which one? Zn 2 plus. Question 12. Which of the following is not a part of the first transition series? You know the first transition series element, right? Can you say scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc? Which is not belongs to this one? Magnesium. Magnesium is in S block, right? It's a metal, right? Now the color of transition metal, very simple. Why? What is the reason for the color of transition metal? DD transition. Yes, all of you? DD transition. The unpaired electron make DD transition and they shows color. Now the melting point of copper is greater than that of zinc because see copper atomic number 29, you know there is an exception in configuration, that is argon 4s1 and 3d10. This is the configuration. What about melting point of copper? What about the greater than that of zinc? Zinc, the atomic number is 30. So what we write? Argon and 4s2 3d10, right? Ready. Now question, why the melting point of copper is greater than that of zinc? See, what is the reason for melting point? See, if that contain more number of unpaired electron, if they're in the system, they form very strong metallic bond. Stronger the bond, they have what? High melting point, right? High melting point and high enthalpy of atomization. So why copper? So zinc, see there is no unpaired electron, but copper in 2 plus you consider. Copper can exist in different oxidation state, right? Copper plus 1 is there, copper 2 plus is there. You consider copper 2 plus. What do you mean by copper 2 plus? 1 electron go from here, 1 electron go from here. It will be 3d9. 3d9 means there will be unpaired electron. Yes, one unpaired electron is there. But in zinc, there is no unpaired electron, so they form very weak metallic bond, so their melting point is very less. So we can say the melting point of copper is greater because the number of unpaired electrons are take part in bonding, which form very strong metallic bond. Copper has BCC, no. Copper has large, no. Copper electrons are involved in metallic bonding. Stronger the metallic bond, higher the melting point. Next one. The zirconium and hafnium. Here where we studied zirconium and hafnium, we know 3D series, 4D series, 5D series, right? In 4D series zirconium, 5D series hafnium, if there, we know 4D and 5D series element shows almost similar atomic size. That is because of lanthanide contraction. We studied the consequence of lanthanide contraction. 4D and 5D series have almost similar size. Because of that, zirconium and hafnium shows almost similar property. So zirconium and hafnium have almost equal atomic and ionic radii. That is because of what? Lanthanide contraction. It is one of the consequence of lanthanide contraction. Electronic configuration of a transition element X in +3 state is given as, that is argon with what? 3d5. Argon and 3d5. What is the atomic number? So electronic configuration of a transition element in its +3 state is given. Okay, +3 state is given to you. What is argon? 18. So 18 plus 5 is equal to 23, right? But it is in their +3 state. What do you mean by +3? Already 3 electron loss. So before, what it was, 3 will be there, 26 electrons will be there in the system. See all, they given the element in +3 state, it is having how many electron? 23 electron. Because +3 state, what is the configuration given? 18 and 3d5. 18 and 3d5. That means the 4s electron, everything is gone. So plus 3, if they ask plus 3 mean already 3 electron loss. After losing 3 electron, how much it's having? 23. So before leaving that 3 electron, how many will be there? We need to add 3. So that will be 26 electron in that. So what is the atomic number is the question. Atomic number will be what? 26. Next question number 17 for you. Metallic radii of some transition elements are given below. Which of these elements will have highest density? You know, density related to what? Density mainly depends on what? Mass by volume, right? Density directly proportional to mass. If you go from left to right, what happened? You know, atomic number increases, right? Electrons are getting added, right? So when you go from left to right, the mass increases, so density increases. Which one is the element present? See, the element scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel and copper. Copper is at the last. Copper is at the last. When you go from left to right, what happened across a period? Atomic mass increases. So what happened? Density also increases. So copper having the greatest density. Alright. So metallic radii actually is given here 126, 125, all nearly same and all given. Anyway, the main factor affecting what? Density is what? Density, it is increases when the atomic mass increases. From left to right, it increases. Now, the magnetic nature of elements depend on the presence of unpaired electron. Yes. Identify the configuration of transition element which shows highest magnetic moment. What is the equation for magnetic moment? Nu equal to root of n into n plus 2, right? What is n? Number of unpaired electron. More number of unpaired electron is there, more magnetic moment. So you check where we having more number of unpaired electron. So 3d7, what do you mean by 3d7? 3d7 means 1, 2, 3, 4, 5, 6, 7. So how many unpaired electron? 3 unpaired electron. What about 3d5? Yes, there will be the maximum 5 unpaired electron. 1, 2, 3, 4, 5. Yeah, 5 unpaired electron. What do you mean by 3d8? 3d8 means how many unpaired electron here? 1, 2, 3, 4, 5, 6, 7, 8. Only 2 unpaired electron. D2 means only 2 unpaired electron will be there, right? So 2. So which one having greatest number of unpaired electron? That's having greatest magnetic moment, that is 3d5. Now, which of the following oxidation state is common for all lanthanoids? Lanthanoids and actinoids, there is a common oxidation state or general oxidation state, that is what? +3. Please remember dear, lanthanoids, okay, lanthanoids group shows a common oxidation state as what? +3. Which of the following reaction are disproportionation? What do you mean by disproportionation? Same species undergo both oxidation and reduction called disproportionation. Check it. Copper, here it is +1 state. Copper, here it is +2 state. And here it is 0 state. So copper +1 converted to +2. What is that? +1 converted to +2 means oxidation. +1 converted to 0 means what? Reduction. So both oxidation and reduction takes place mean yes, it is disproportionation. So first is disproportionation. What about MnO4 2-? What is the charge of Mn in MnO4 dear? We can take it as Mn is X and 1 oxygen -2. So 4 oxygen -8 overall -2. So X equal to what? +6. So here Mn is what? +6. What about here Mn? MnO4 minus mean Mn is in +7 state. Yes or no? Because Mn is X. 4 oxygen -8 and overall equal to -1 and equal to +7. And here MnO2 mean Mn will be +4. See all, +6 converted to +7. What is that? +6 converted to +7. Increase in oxidation, right? That means oxidation. +6 converted to what? +4. That is what? Reduction. Yes, so that is also a disproportionation reaction. What about this case? KMnO4. KMnO4 manganese is in. Manganese is in +6 +7 oxidation state. In K2MnO4 you calculate Mn will be +6 state. MnO2 it will be +4 state. Alright. So here you just analyze +7 converted to +6, right? Decrease means what? Reduction. +7 also converted to decrease, reduction. That is not both oxidation and reduction. Both are reduction. So it is not disproportionation. And here you observe all, only one manganese here. Okay, let us check it. Here Mn is +7. Alright, here Mn is already +2. And here it is what? +4. Right? +4. Is it oxidation or reduction can we say that here? No, that is only 1 and 2 is possible, right? So 1 and 2. So what is the basics idea? If an element, if same species undergo both oxidation and reduction, then what it is called? Disproportionation reaction. 21. Gadolinium belongs to 4f series. Atomic number is 64. What is the correct electronic configuration? Here, gadolinium 64 means we can use xenon configuration. What is xenon atomic number? 54. What is other 3 orbital? We have 4f, 5d and 6s. After 54 xenon, what is the orbital we have? 4f, 5d, 6s. Do you know the filling of electron? The way of filling of electron is like this. Let's have understanding. After 54, next 2 electron we should fill here. 1 electron fill it here and 14 electron we have to fill it here. Basics. After 54, 2 electron here, 1 electron in 5d, 14 electron in 4f. If you have some more electron to fill, come back to 5d, fill up to 10. So here we need to fill 64, right? Already 54 over. So 10 more electron we need to fill it. Okay, let us fill 2 here, 1 here, 7 here, right? That is the configuration. So xenon, 4f7, 5d1, 6s2, that option A itself. 22. Interstitial compound. What are interstitial compound? In the transition metal, the small gaps are there. That's called the what? Interstitial site or void. Where small elements like carbon, hydrogen, oxygens are trapping, they're called interstitial compound. Interstitial compounds are formed when small atoms are trapped inside the crystal lattice. Which of the following is not the characteristics property? You may study 4 properties of interstitial compound. They are very hard. They have very high melting point compared to the pure metal. They retain their metallic conductivity and they are chemically inert. So they have high melting point as compared to pure. Yes. They are very hard. Yes. They retain their metallic conductivity. Yes. They are chemically very reactive. No. Interstitial compounds are chemically inert. All right. D. Next one, KMnO4 act as an oxidizing agent in alkaline medium, even acidic and neutral, every medium. When alkaline KMnO4 is treated with a Ki, the iodide ion is oxidized too. Please note it, all of you. If your medium is KMnO4, if the oxidizing agent is KMnO4, in acidic medium, the iodide converted to I2, and in neutral or faintly alkaline medium, the iodide converted to iodide IO3 minus. Alright. So in KMnO4, in alkaline medium, convert iodide to what? IO3 minus iodide. That is option C. Alright. So in acidic medium, I minus converted to I2. In alkaline or neutral medium, I minus converted to IO3 minus. When acidified K2Cr2O7 solution is added, you know, K2Cr2O7, potassium dichromate, it is also a very strong oxidizing agent. It convert what is SN2 plus called stannous. Stannous becomes stannic. What is stannic? SN4 plus. Please note it all. What all conversions are done by K2Cr2O7. K2Cr2O7 convert iodide to iodine. Iodide to iodine, and sulfide S2 minus 2 sulfur, sulfide to sulfur, ferrous to ferric. Okay, ferrous to what? Ferric. And here what? Stannous mean SN2 plus, it becomes stannic SN4 plus, right? So conversion is important. What to what? Next. So here the question, stannous to what? Stannic. Next one, highest oxidation state of manganese in fluoride is +4. Mn for F4 mean Mn is in +4 stat, but highest oxidation state oxide is +7. You know what is the reason? We know higher oxidation state of transition metals are stabilized by only fluorides and oxide. Reason, fluorine and oxygen are most electronegative element, but compared to fluoride and oxide, oxides make more stability, or oxides form very higher oxidation state. Here you see fluoride form +4, but oxide can form +7. Why? Because when metal bonded with the fluorine only can form single bond with the metal. But when metal bonded with oxygen, they can form double bond with the oxygen. So who tried to take maximum electron from the metal? Oxygen. Okay, fluorine and oxygen both are highly electronegative element, but oxygen have an ability to form double bond with the metal, so they will take more electron from the metal, make it more oxidation state. So can you say what is the reason why fluoride shows less oxidation, oxide shows more oxidation state? We can say in covalent bond only while oxygen form double bond. Okay, so because we can say in covalent bond only while oxygen form double bond. Oxygen have an ability to form double bond, therefore it shows. Fluorine is more electronegative than oxygen. Yes, correct. But this is not reason for oxygen why it making more oxidation state mean oxygen can have ability to form double bond with the metal. Next one, although zirconium belongs to 4D transition series, already we discussed zirconium and hafnium. Zirconium is in 4D, hafnium is in 5D. Series why they have similar property due to lanthanide contraction, right? That's a consequence. Both have same number of electron, both have similar atomic radius, both belongs to same group of the periodic table. What is that? Both have similar atomic radii. Due to lanthanide contraction, 4D and 5D series elements have almost similar atomic radii. Therefore, zirconium, hafnium, similar properties. Why HCl not used to make the medium acidic in oxidation reaction of KMnO4 in acidic medium? Normally, when you do volumetry titration and all, KMnO4, if you want to acidify from the burette, when you add KMnO4, you will acidify it with what? H2SO4, right? We won't use HCl. Why? Dear, KMnO4 is a very strong oxidizing agent. So it will oxidize the HCl to what? Cl2. Okay, so KMnO4 is a strong oxidizing agent. It oxidizes the HCl to what? Chlorine gas. So KMnO4 oxidizes HCl into Cl2, which is also an oxidizing agent. So take care about that point. KMnO4, if you want to acidify, only H2SO4 we are using. HCl we won't use it because KMnO4 convert HCl to which one? Cl2. Next, what is a general, simple question, what is the general electronic configuration of transition metal? What is the general electronic configuration of transition metal? N-1D, 1 to 10, 1 to 10 and Ns 1 to 2 or 2. Yes, where it is N-1D, 1 to 10, Ns2, option A, right? Okay, yes. Next one. Which of the following pair of ions have same electronic configuration? Same electronic configuration if it having, what is that meaning? They have same number of electrons. They have same number of electrons, therefore they show same number of which one? Same electronic configuration, right? Okay, you just analyze later. Now I am going for the answer. Answer will be B. Let me just check it. Fe, what is atomic number here? 26, right? So what is the configuration? Argon. Okay, no need to write the configuration and all. Fe atomic number 26. So what do you mean by Fe? 3 plus 3 electron loss, right? So 23 electron will be there. All right. So Fe means 26. Okay, not that. Okay, let us just to go for that one. Ready. Copper, scandium. Okay, let's check it. So Fe is atomic number 26. So Fe 3 plus mean only 23 electron. What about Mn? Mn atomic number is 25. So Mn 2 plus means what? 2 electron loss. So that is also what? 23. So if they have same number of electron, their configuration will be same one. Right. Next. The second and third row element of transition, which is the second and third row, 3D, 4D, 5D. So second and the third row means which one? 4D and 5D. Okay. The second and third row element of transition metal resemble each other much more than. Already again we discussed what? Due to the lanthanide contraction. So lanthanide contraction which results in almost same radii of second and third. Yes, option A. Alright, so 3D is the first transition series, 4D and 5D are the second and third transition. Ready. 31. Reactivity of transition element decreases almost regularly from scandium to copper. Why scandium to copper? The reactivity of the metal decreases. Is it due to lanthanide contraction? No. Regular increase in atom ionization enthalpy. Regular increase, left to right, what happened here? Left to right, atomic size decreases. Atomic size decreases mean ionization enthalpy increases. What is mean by ionization enthalpy? Amount of energy required to remove an electron from the outermost shell. So smaller the size mean high nuclear charge, very difficult to remove electron. So left to right, ionization enthalpy, what happened? Increases, very difficult to remove electron. So the reactivity decreases. Now, copper plus ion, Cu plus ion is not stable in a aqueous solution because you may study this question like this one. Why copper in +1 state is unstable in aqueous solution, whereas copper 2+ is stable in aqueous solution? Yes or no? Why copper salt in +1 state is unstable in aqueous solution, but why copper 2+ is stable in aqueous solution? Reason you may study copper 2+ having large negative hydration enthalpy. Copper 2+ having large negative. You know, when we can say that a oxidation state is stable, that depend on total energy. The total energy is the sum of ionization energy, hydration enthalpy, and enthalpy of atomization. Enthalpy of atomization. The sum of these three energies called the total energy. If the total energy is negative, stable the oxidation state. If the total energy is negative overall, stable the oxidation state. You see, copper 2+ having large negative hydration energy. So higher the hydration energy, if 2 negative in value, total energy will be negative, stable the oxidation state. So what is the answer? Second ionization enthalpy of copper is less than the first ionization. Large value of second ionization enthalpy of copper is compensated by much more negative hydration energy of which one? Copper 2+, right? Copper 2+. See, large value of second ionization enthalpy of copper is compensated by much more negative hydration energy of which one? Copper 2+. Therefore, copper 2+ is more stable, whereas copper +1 is unstable. Right. The first ionization energy of the element of first transition series titanium to copper. Just we discuss now, left to right means when you go across a period, atomic size decreases, ionization enthalpy increases. So we can say increases as the atomic number increases, first ionization. 34. The standard electrode potential of manganese 3+ to Mn2+ is high positive. A small hint, let me give you all. If they given you a metal manganese 3+ to manganese 2+, this value, what they said, high positive, right? High positive means there is a small hint, let me give you. If it is high positive in value, its 2+ state will be more stable. Okay, if the E0 value of a metal 3+ to metal 2+, if they given more positive in value, its +2 state basically will be more stable. So let me check it. Mn is the element, right? Mn is 25. So you know the configuration is what? Argon 4s2 3d5. So Mn2+, let me take it. What it will be? 3d5. Yes, it is stable. Okay, so when a metal, if they given you with a high positive in value with this 3+ to 2+, its +2 state basically stable. So what you can say, Mn2+ is D5 can be easily oxidized to Mn3+ D4 due to low ionization. No, the third ionization enthalpy of Mn is much larger due to stable half-filled. Third ionization enthalpy of Mn is much larger due to stable half-filled D5 configuration of Mn2+. Yes, Mn3+ more stable. No, option B. Option B. What is that point? Third ionization enthalpy of Mn is much larger. Yes, dear. See, Mn, what is Mn configuration? 3d5 4s2, right? So if you apply first ionization enthalpy, what happened? One electron goes. What it become? 3d5 4s1. If you apply second ionization enthalpy, one more electron go, it become 3d5. 3d5 means stable mean, yes, if it is stable, if you want to remove one more electron, you have to apply third ionization enthalpy. It will be greater because it's already stable. So third ionization enthalpy of manganese is much larger due to the half-filled D5 configuration of Mn2+. Yes, Mn2+ is what? D5. So overall, if they said the electrode potential is this is high positive, what you want to show that the +2 state will be highly stable. Ready? Now, Fe3 plus compound are more stable than Fe2 plus compound. Why? We studied Fe atomic number is 26. So configuration is what here? Argon 4s2 and 3d5. So Fe2 plus means what? This 2 will go. Sorry, this is 6, right? Yeah. Fe2 plus means what? 3d6. What do you mean by Fe3 plus? One more electron go from here. 3d5. Yes, it is half filled. So Fe3 plus compound are more stable. What you can say? Fe3 plus has 3d5 configuration. Yes. And copper sulfate is paramagnetic while zinc sulfate is diamagnetic. Why? Here copper sulfate, copper, what is the charge of copper 2 plus, right? Zinc sulfate, what is the charge of Zn? Zn 2 plus. Okay, let us check it all. Copper atomic number is 29. You know the exception in configuration, it is 4s1 3d10. But what do you mean by copper 2 plus? Copper 2 plus mean one from here, 3d9. What do you mean by 3d9? 3d9 you will fill 1, 2, 3, 4, 5, 6, 7, 8, 9. There is an unpaired electron. If the system having unpaired electron, they can show DD transition, become colored. But Zn case, you know, Zn in ground state and in Zn 2 plus state also, no unpaired electron. It is what? 3d10. So no unpaired electron means what? They cannot show DD transition. So it is colorless. So what you can say? Copper 2 plus ion has 3d9 configuration while Zn2 plus has 3d10 configuration. Yes. 3d5 no. Copper 2 plus has filled orbital no. Copper sulfate no. Right. Next one. Which of the following statement is not correct about magnetic property of metal? Diamagnetic substances are repelled by an applied. Yes, paramagnetic substances are attracted by the external magnetic field. Diamagnetic substances are repelled by the magnetic field. Paramagnetic substances are attracted by, yes. Magnetic moment, here it is wrong. What is the mistake in this question? You know, magnetic moment is root of n into n plus 2, not n minus 2. Careful. Next one. Most of the transition metals exhibit. Paramagnetic, yes dear, most of the transition metals having high unpaired electron, they are paramagnetic, not diamagnetic. They show variable oxidation state. Yes, they form color also. So 1, 3, 4, 1, 3, 4. Yes, these all are what? Correct. Next one. Transition metals makes the most efficient catalyst because, already we discussed this one. Why transition metal shows variable oxidation, why they shows different catalytic activity, why they use as catalyst? Because of main two reasons. They shows variable oxidation state and they provide large surface area. So where is that? They adopt a multiple oxidation state. They show variable oxidation state. Form color, show paramagnetic for a large number of oxide. No. Reason for catalytic activity is what? It forms what? Variable oxidation state. Interstitial compounds are. Interstitial compound we discussed already. In the crystal metal, small gaps will be there. In the void, some small elements like oxygen, hydrogen, carbon are trapped. They're called interstitial compound. Interstitial compounds are non-stoichiometric and neither ionic nor covalent. Interstitial compounds are non-stoichiometric and they are neither typically ionic nor covalent in nature. Not at all. Interstitial compounds are stoichiometric compound. They don't have stoichiometry, non-stoichiometric compound, and they're neither ionic nor covalent in nature. 41. Arrange the oxide of manganese according to increasing acidic strength. See, acidic strength if they ask. Acidic strength if they ask, calculate the oxidation state. Acidic strength is directly proportional to what? The oxidation state of the metal. In MnO, you know how to calculate the charge of Mn, right? In MnO, what is the charge of Mn dear? In MnO, Mn is +2 charge. What about Mn3O4? Mn3O4 mean there will be 3 manganese, right? So 3x minus 8 equal to 0, x equal to what? 8 by 3, right? Next one, Mn to 8 by 3 is nearly what? The near value is enough. Okay, 2 point something will be there, right? Okay, 2 point something will be there. Now, what is Mn2O3? 2 manganese. So 2x minus 6 equal to 0, x equal to what? +3. And MnO2 mean manganese is +4. Mn2O7, 2x minus 14 equal to 0. So 2x equal to 14, x equal to what? 12. 6, right? Sorry, it will be 6. 7, right? Sorry for that. So 2x equal to 14. So x equal to what? Plus 7. So greater the oxidation state, greater the acidic strength. So which one having greatest? So here plus 2, here more than 2, here 3, here 4, here 7. So same order, right? Option A is the correct. So where the metal shows higher oxidation state, where there will be higher charge, right? Higher acidic strength and oxidizing power. Okay, is that clear, that point? This is the same question. This is the same type of question they asked in 2024 board question, right? Okay. Next one is potassium dichromate. What is potassium dichromate? K2Cr2O7 is preparing from, potassium dichromate K2Cr2O7 is preparing from which ore, dear? Chromite ore. Chromite ore. What is chromite ore? FeCr2O4, right? Chromite ore. Whereas KMnO4, potassium permanganate, is preparing from where? Pyrolusite ore. What is pyrolusite? MnO2, pyrolusite. Do you remember the preparation? Very sure question for board exam. There are 3 steps in this preparation. There are 2 steps in this preparation. Can you say the 3 steps here? The chromite ore, first we treat with the sodium carbonate and oxygen, right? Chromite ore, we treat with the sodium carbonate and oxygen. It becomes what? Sodium chromate. Sodium chromate. Sodium chromate, second step, we treated with what? Acid, H2SO4. It becomes sodium dichromate. Sodium dichromate, when you treated with the KCl in third step, it becomes potassium dichromate. Please study the preparation. Potassium dichromate is preparing from chromite ore with the sodium carbonate and free access of air. 43. Which of the following compound is used as the starting material for the preparation of potassium dichromate? Just we discussed which one? Chromite ore, FeCr2O4. Okay, FeCr2O4. Yellow colored aqueous solution of sodium chromate changes to orange when acidified with the sulfuric acid because. Carefully listen that point all. Yellow colored aqueous solution of sodium chromate. What is sodium chromate? Na2CrO4. Na2CrO4. That just we discussed now. Sodium chromate is yellow in color. That means chromate is yellow in color. Okay, chromate is yellow in color. This chromate we will acidify in second step with the sulfuric acid. Sulfuric acid, it will, the Na2CrO4 become Na2Cr2O7, sodium dichromate. Sodium chromate on acidification becomes what? Sodium dichromate. And dichromate is what? Orange red in color. Orange red in color. So chromate on acidic medium becomes what? Dichromate, that is orange red. So what is the reason? H plus ion convert chromate ion to what? Dichromate ion, or formed during the reaction which impart orange color to the solution. No, which one? That H plus ion convert. It means H2SO4 is H plus, right? H plus ion convert chromate to which one? Dichromate. Chromate is yellow color, dichromate is orange red in color. Next one. What happens when potassium iodide react with the acidic solution of potassium dichromate? We discussed potassium dichromate convert iodide to what? Iodine. Iodide to what? Iodine. Iodide to what? Iodine. But that's not the, it will liberate iodine. Yes, correct. Potassium sulfate is formed. Chromium sulfate is formed. All of the above. Dear, very carefully to study the reaction. Potassium dichromate, when react with the acidic medium, it convert iodide to iodine. Yes, it is correct. Iodide to iodine. Yes, it is there. Along with that byproduct also you should study. Potassium sulfate form, chromium sulfate form, water also there. So what is that? All of the above products are formed. So all of these, such an option is there. It's our duty to cross check it. Okay, so all of the above. Now, acidified potassium dichromate, that means K2Cr2O7 in acidic medium, react with the potassium iodide and oxidizes to iodine. Yeah, potassium iodide Ki, which means I minus is there. I minus converted to I2, correct. What is the oxidation state of chromium in the product? Dear, carefully understand. If it is potassium dichromate, actually potassium not required here, dichromate is the acting one, that is oxidizing agent. That means Cr2O7 2 minus. So in reactant side, how dichromate is there? Cr2O7 minus. When it is after oxidation, it becomes Cr3 plus. So they're asking in product side, what is chromium oxidation state? That is +3 oxidation stage. Remember all, in acidic medium, potassium dichromate or the dichromate converted to which state? +3 state. Ready? 47. Identify the correct structure of dichromate. Here it is compulsory to know the structure of chromate and dichromate. What is the structure of chromate? What is chromate? CrO4 2 minus, yellow in color, okay? Its structure is tetrahedral, double bond O, O minus, O minus. This is the structure of chromate. Here they are asking dichromate. What is dichromate? Cr2O7 2 minus, orange red in color. Its structure is Cr double bond O, O minus. Same one, another Cr double bond O minus, and in between there is a bridged oxygen. This is the structure of Cr2O7 2 minus. Can you check it? Where is this? Where is this? Cr double bond O minus, O Cr double bond O minus, right? Let's go with option A. Now, when MnO2 is fused with the KOH and O2, what is the product form? Here it is in the preparation of KMnO4. It is the question from preparation of KMnO4. 2 steps are there. Please study all. MnO2 is called pyrolusite ore. When pyrolusite ore, when react with the potassium hydroxide along with the oxygen supply, it becomes a dark green colored K2MnO4 called what? Potassium manganate. Okay. You know what is the second step? How you convert potassium manganate into potassium permanganate? This potassium manganate treat with acid, it become potassium permanganate, that is K2MnO4. Only 2 steps are there. Please study. So what is the dark green color? K2MnO4, that is the product in first step. Now, the equation MnO4 2 minus plus H plus. So, this is what? Permanganate, right? MnO4 2 minus, no. MnO4 2 minus, right? Not permanganate, that is MnO4 minus. So, MnO4 2 minus on acid, it becomes MnO4 minus. Okay, they are given a reaction. This reaction belongs to which type? Which type it is? Can you say? Mn, what is the oxidation state? Please find it all of you. Mn, take it as X. 1 oxygen minus 2, 4 oxygen minus 8, overall minus 2, so X equal to what? Plus 6, right? Here Mn is plus 6 state. What about product? Here Mn you calculate, it will be plus 7 and it is what? Plus 4. Plus 6 converted to plus 7. What is that? Increase in oxidation means that is what? Oxidation. And plus 6 converted to plus 4, decrease in number mean that is what? Reduction. Both oxidation and reduction happen to the same species. What do you call that? It is called disproportionation reaction. Question number 50 for you all. We are going for the 50 question. Which of the following is correct representation of acidified permanganate? Okay, acidified permanganate solution with a sulfurous acid. You know what is sulfurous acid? The ion present, it's also called a sulfite, that is SO3 2 minus. You should know first of all, KMnO4 as KMnO4, right? KMnO4 means how the ion is existing. We will write MnO4 minus. KMnO4, right? MnO4 minus. Permanganate, right? Yeah. Permanganate is what? MnO4 minus. Acidic medium, right? So what will be the H plus, right? Sulfurous acid is, they will written as SO3 2 minus. SO3 2 minus is called sulfurous acid or sulfite. And you should have an idea what all changes are going to happen for each thing. Carefully, very simple. During in acidic medium, MnO4 minus, that is our permanganate ion converted to Mn2 plus. Do you remember dichromate ion converted to what? Cr3 plus. Here MnO4 minus converted to Mn2 plus. And H plus becomes H2O. And sulfite becomes sulfate, SO4 2 minus. These are the overall changes. Check it where it is. MnO4 minus, SO3 2 minus, H plus, SO4 2 minus, Mn2 plus. Mn2 plus, not Mn plus. So, Mn2 plus, where is that? Okay, MnO4 minus, SO3 2 minus, not H2O. H2O should not be in this side, only acid should be there. See, H2O is all mentioned in this side, right? No. So MnO4 minus plus SO3 2 minus plus H plus give SO4 2 minus N. Mn, this will be I think 2 plus. Okay, that's a mistake. 2 plus N 3H2O. Right. So basics are okay. MnO4 minus is there. SO3 2 minus is there. H plus is there. SO4 2 minus is there. Mn2 plus. Okay, mistake is there. So I'm correcting as Mn2 plus and H2O. Ready. And balancing or not checking out 2 Mn. Okay, 2 Mn. 5 sulfur. Yeah, 5 sulfur. 6 hydrogen. 3H2 means 6 hydrogen. Oxygen 2 into 4 8. 8 plus 15 23. Here 20. Yeah, 3 oxygen. Right. Option A. 51. The trend of basicity of lanthanoid hydroxide. Lanthanoids, we can say lanthanum to what? Lutetium, right? Lanthanum to lutetium. Lanthanum, basic charge of lanthanides we discussed what? 3 plus. So lanthanum when combined with the hydroxide, you get lanthanum hydroxide LaOH thrice. Lutetium hydroxide is LuOH thrice. We know lanthanum to lutetium means across a period. Across a period, atomic size decreases. Across a period, atomic size decreases. Atomic size decreases means what happened here? Lutetium is smaller in size. So lutetium hydroxide bond will be very strong. Yes or no? Lanthanum to lutetium size decreases. So lutetium size is small mean lutetium with the OH group is very strong bond. Stronger the bond, it can't lose OH faster. Therefore, it bond least basic. Least basic. So, lanthanum to lutetium, what happened to the basic character decreases. It's a consequence of lanthanide contraction. So, the trend of basicity of lanthanide decreases across the lanthanide series. Next one, what is the chemical composition of mish metal? One which is used in bullet and shell coating and all, right? Mish metal. Mish metal is, okay, it's actually an alloy. It is an alloy of 95% a lanthanoid element. Basically, we are using cerium. 95% lanthanoid and 5% iron and traces of sulfur and all we are using. Where it is 95% of actinoid, no, 95% lanthanoid. 95% of lanthanoid metal with 5% iron and traces of sulfur, carbon, calcium, aluminum is called mish metal. What is the total number of inner transition element? What do you mean by inner transition element? Nothing but F block element. How many F block elements you have? 14 elements are in lanthanoid, 14 elements are in actinoid, 14 plus 14, 28 elements are there in F block. What is the shape of d orbital? D-orbital dumbbell shape, right? D-orbital dumbbell, which dumbbell? Double dumbbell shape, right? So p orbital, s orbital spherical shape, p orbital dumbbell shape, d orbital double dumbbell shape, right? Double dumbbell in shape. Which of the following is diamagnetic? Already we discussed diamagnetic mean no unpaired electron. Where you don't have no unpaired electron, you cross check it one by one with the element. Let me go for mercury. Why mercury? Do you remember we studied zinc, cadmium and mercury. Zinc, cadmium and mercury are in the same group. They do not contain any unpaired electron. Zn atomic number 30, configuration is 4s2 3d10. Cadmium is 5s2 4d10. Mercury is 6s2 5d10. So you see mercury is in 2 plus mean d10. D10 mean what? D orbital is fully filled. Zinc, cadmium, mercury, their ground state, even their oxidation state, their d orbital is what? Fully filled, no unpaired electron. So it is diamagnetic. Which of the following is not a part of the first transition series? Again, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, which is not belongs to this one. Again, that's what already I think that discussed. That's a magnesium is the one. Cobalt, chromium, nickel already there in 3D series. Transition metals show high enthalpy of atomization. Why? We said that transition metals contain high number of unpaired electron. If it having more number of unpaired electron, they form strong metallic bond. Their metallic bond will be very strong. If they have more number of unpaired electron, they form very strong metallic bond. Stronger the metallic bond, very harder to separate them. So that means they have high enthalpy of atomization. High enthalpy of atomization, which means amount of energy required to break into their atom. Stronger the bond, high enthalpy of atomization. What is the transition metal show high enthalpy? They are variable oxidation, they know, colored no. More unpaired electrons are involved in metallic bonding. Yes. 58, come on. What happened when ferrous ion react with an acidic potassium dichromate? What is potassium dichromate here? Cr2O72 minus. Acidic medium means what? H plus. Ferrous mean what? Fe2 plus we studied. Dichromate ion, what it becomes? Cr3 plus. H plus, what it become? H2O. Ferrous, what it become? Ferric. Ferrous to ferric. So we can say the formation of what? Ferric ion. Next, acidified potassium permanganate. What is potassium permanganate? MnO4 minus. Acidified mean what? H plus. Combine with the potassium iodide. Potassium iodide contain iodide, right? Iodide and forms I2. Yes, it forms I2. I minus converted to I2, H plus converted to what? H2O, and MnO4 minus 1 converted to what? Mn2 plus. What is the manganese oxidation state in the reaction? Means what oxidation state in the reaction in product? Okay, reaction in product. In product side, what is the oxidation state of manganese? Mn2 plus, right? 2 plus is the oxidation state. 60. In the dichromate anion, Cr2O72 minus. Its structure already we noted like this, right? Its structure is what? Cr double bond O, O minus, and OO, Cr, sorry. That's we have Cr double bond O, O minus. This is the structure of which one? Dichromate ion. Dear all, in dichromate ion, bond is very careful. Can you see this 6 bond? 1, 2, 3, 4, 5, 6. The outside terminal bond, their bond length is around 163 picometer. These all three means total 6 bond, their bond length is what? 163 picometer. Whereas the bridged one is around 179 picometer. The bridged one is 179 picometer. So in Cr2O72 minus dichromate ion, 6 CRO bonds are equal in length, which all 1, 2, 3, 4, 5, 6. So you may say, sir, this is double bond and single bond, right? How their bond length is same? Here, there is resonance is possible. In dichromate ion, resonance is there. So the double bond can be on any side. So all the CRO bonds, 6 CRO bonds are similar, but these two are different in length. So we can say all CR bonds are not the same. The 6 CRO bonds are same in length. Next one, which metal is used as an electroplated protective coating? Electroplating. Where we are using chromium is the metal we are using for electroplating. Next, filling the missing product in the following reaction. What is this? MnO4 minus permanganate. Which medium? Acidic medium. What is that? I minus. In acidic medium, I minus converted to what? I2. I minus converted to I2. But this is again permanganate. Water and iodine. Again iodine converted. But this is what? H2O, dear. Medium is, first one is acidic. Second one is neutral. In neutral and alkaline medium, iodide converted to what? Iodate. That is IO3 minus. Already we discussed that. So one is I2, second one is IO3 minus. 63, the total number of unpaired electrons in Mn3 plus. See, Mn atomic number is 25. So configuration is what? Argon with 4s2, 3d5. So what is the number of unpaired electron in Mn3 plus? 3 plus mean 2 from here, 1 from here, 3d4, right? So there will be 4 unpaired electron. Chromium, what is the atomic number? 24. You know the exception in the configuration, that is argon, 4s1, 3d5. But here chromium, 3 plus they are asking 1 from here, 2 from here, 3d3. So how many unpaired electron? 3 unpaired electron. What about last vanadium? Scandium, titanium, vanadium, 23. So 23 means what we can write? 4s2, 3d3. But vanadium 3 plus mean 2 from here, 1 from here, 3d2. How many unpaired electron? 2 unpaired electron. Ready? So, question, what is the total number of unpaired electron and the most stable species? Check it. So, unpaired electrons are what? 4, 3, 2, right? 4, 3, 2. 4, 3, 2. So, D and B, we can cut it. 4, 3, 2. Which is more stable? D4, D3, D2. Which is more stable? D3. Why D3 is more stable? D3, which is more stable because when this orbital splitted, 3 orbital goes to T2G, the 2 orbitals remain empty. T2G at least is half filled, right? Since T2G orbital is half filled, D3 configuration is stable. So we can say 4, 3, 2 and Cr3 plus is the most stable one. Question 64. In alkaline solution, MnO4 minus changes to what? We already studied MnO4 minus, that is what? Permanganate ion. Permanganate ion. In acidic medium converted to Mn2 plus, okay? MnO4 minus is the permanganate ion which will convert it to Mn2 plus in acidic medium. But here they are asking you in alkaline medium, in aqueous or alkaline, neutral or alkaline medium, MnO4 minus converted to MnO2. Okay, MnO2, so answer is B. Remember all, in acidic medium, MnO4 permanganate converted to Mn2 plus, in alkaline medium converted to MnO2. Ready? Let's go for the next question. Which of the following is colorless ion out of the following? Colorless ion means they do not contain any unpaired electron. Where is no unpaired electron? Can you check it, all of you? Let me just, you can cross check it, right? So let me just take titanium. What is titanium? 22. 22 means what is the configuration? Argon with the 4s2 3d2. What do you mean by titanium 4 plus? All 4 electron gone. What is left? Argon. Argon means fully filled, no unpaired electron. No unpaired electron means what? It will be colorless. So titanium 4 plus. Which of the following statement concerning trans-uranium element is incorrect? What is trans-uranium element? The elements coming after uranium. Uranium atomic number 92. So after the element uranium, the elements are called trans-uranium element. They are highly radioactive elements. So their atomic number is greater than 92, correct? Example is thorium. No, thorium is not there. Thorium is 90. It is not belongs to trans-uranium. DK there show radioactive and elements after uranium. Yeah, the elements after uranium 92 above, they are called what? Trans-uranium elements. They are radioactive. Select the appropriate statement. Correct one. Both actinoids and lanthanoids are less basic. Both actinoids and lanthanoids are electropositive. Yes, they are metal. Both actinoid and lanthanoid do not exhibit magnetic and spectral property. No. Both actinoids and lanthanoid do not show same oxidation state of which one? +3. So the main thing, both actinoids and lanthanoids are what? They are electropositive. You may studying their similarity and dissimilarity between lanthanides and actinoids. So careful all. Both lanthanoids and actinoids shows what? They are metallic in nature, so they are electropositive in nature. Now, what happens to the atomic size of lanthanides as the atomic number increases? Atomic number always what? Left to right, what happened? Atomic size decreases, but due to lanthanide contraction, it is a steady but slow decrease in size. That's it. So the radius remain unchanged, or radius first increases, no. The radius what decreases? Whenever you go from left to right across a period, atomic size decreases. Which of the following is not a lanthanide property? They are soft metal with a white silvery color. They tarnish rapidly by air. The hardness of the metal increases with increase in, and the melting point of the metal range from 500 to 1000. No, it's more than 1000 here. It's already forgiven. Melting point of the lanthanide ranges from 1000 to 1200, not 500 to 1000. What is the lanthanide's first element? You know, lanthanides starting from where? Lanthanides final element they're asking. Lanthanides are starting from cerium to lutetium. Actinides are starting from thorium to which one? Lawrencium. Okay, what is the lanthanide final element? That is what? Lutetium. Lutetium is the final element. The property which is not characteristics of transition metal is, which is not a property of transition metal. They variables show yes, tendency to form color yes, formation of colored yes, natural radioactivity. No transition elements are not radioactive, but lanthanide, actinide cases and all, there were more actinide and all more radioactive elements are there. The pair of which both the elements generally shows only one oxidation state is, which will shows the pair shows only one oxidation state. That is our scandium and zinc. We studied scandium shows only one oxidation state +3, and what is the oxidation state of zinc? Always +2. Scandium and zinc shows only one oxidation state. Which of the following characteristics of the transition metal is associated with a higher catalytic activity? Again, variable oxidation state, high catalytic activity because of two reasons, because of variable oxidation state and which one? They provide large surface area. So variable oxidation state. Now in KMnO4, what is the oxidation state of Mn? Simple question. Potassium, what is the oxidation state? 1. Manganese, we don't know. 1 oxygen -2, 4 oxygen -8, overall 0, x equal to what? +7. In KMnO4, manganese is in +7. Transition elements show variable oxidation state due to the loss of electron from which of the following orbitals? Transition elements show variable oxidation state because its n-1d orbital and ns orbital have almost similar energy, so those electrons can take part in bonding. So from where they lose electron? From ns and n-1d, n-1d and ns. 76. The structure of manganate and permanganate are. What is the structure of manganate? Manganate is MnO4 2-. Permanganate is MnO4-. Ready? So MnO4 2 both having tetrahedral structure. Tetrahedral structure. This is manganate, and permanganate will be Mn double bondo, double bondo, double bondo, O-. Both having tetrahedral structure. Tetrahedral. Even chromate and dichromate also tetrahedral. What is the oxidation state exhibited by actinium? Actinium. What is the oxidation state exhibited by actinium? Actinium, the elements, actinoids and all, the general oxidation state is which one we discussed? +3. Common oxidation state, okay, actinium. So just to check it all of you, actinium atomic number is 89. How we write 89? We can write it as the configuration, we can take it radon. Radon atomic number is 86. Okay. After that we have 5f, 6d and 7s orbital. So after 86, 3 more electrons are there, 2 here, 1 here. See, whenever they lose these 3 electrons, they get noble gas configuration. So +3 is their state. Where does the last electron of D-block elements go? D-block, if it want to be D-block element, the last electron should go to D orbital, which is that n-1 d orbital, because what is the general electronic configuration of D-block element? n-1 d, 1 to 10, right? 1 to 10 and ns 1 to 2 or 2. So where the last electron is entering after filling s, electron comes to n-1 d. 79. What is the common oxidation state of scandium? Just we discussed the scandium common oxidation state is 3+, because you know the reason, scandium atomic number is 21. So configuration will be argon 4s2 and 3d1. So scandium 3+ mean what? It will lose this 3 electron. So argon is stable. So scandium shows +3 oxidation state. Identify the incorrect statement. So that's the question, right? What is the common oxidation state? Yeah. What identify the incorrect statement among the following? D-block elements show irregular and erratic chemical properties among themselves. Lanthanum and lutetium have partially filled d orbitals only. The chemistry of various lanthanides are very similar. 4f and 5f orbitals are equally shielded. What is the answer? D. 4f and 5f, dear. 4f is lanthanoid, 5f is actinoid. You know, actinoid contraction is more than lanthanide contraction because due to the very poor shielding effect of it, which one? 5f. They said 4f and 5f having same, no? 5f having very poor shielding effect than 4f. Therefore, actinoid contraction is more than lanthanoid. The elements which contain incompletely filled d orbital either in ground state or in their oxidation state. What do you call? Transition element. If it want to be a transition element, the element should contain incompletely filled d orbital either in their ground state or in their oxidation state. Silver, Ag, silver atomic number 47, its configuration, krypton is atomic number 36. Remaining we have 5s1 and 4d10. This is the configuration of silver, okay? Silver atomic number 47 is the configuration. Silver actually contain completely filled d orbital in their ground state, but it is considered as a transition element. Here, if it want to be a transition element, what is the condition we said? Either in ground state or in excited state, oxidation state, they should have a incompletely filled d orbital. This is ground state. Let me check the excited. Silver shows two oxidation state, +1 and +2. Let me take +2. +2 state mean one from here, one from here. What is left? 4d9. See, the d orbital is incompletely filled in its oxidation state. Therefore, it is a transition. So, this having a incompletely filled d orbital in its +2 state. Question 83. Which of the following element shows less melting point in 3D series? We know scandium, titanium, vanadium, chromium, manganese. You know this graph, you may study it in class also. In this compound here, you may have seen that you can able to see this. This is the 3D series. Okay, please observe this graph. This is the melting point increasing. Atomic number is increased. This is titanium, vanadium, chromium, manganese. Which one having low melting point mentioned? Manganese. Why? When an element show high melting point, first of all, if more number of unpaired electrons are taking place in the reaction, in the bonding, they form strong metallic bond, so their melting point will be high. Manganese, manganese, the configuration is what? 4s2 3d5. It is a stable one. It's half-filled stable, right? Since manganese is having a stabilization, the all electron cannot take part in bonding. So, less number of unpaired electrons only can take part in bonding. Therefore, it form weak metallic bond. Weak metallic bond means less melting point. Okay. So, among which of the following element shows less melting point among this element is manganese. Reason if they ask, manganese having half-filled stabilization, stable the compound, all unpaired electron cannot take part in bonding. So, they form weak metallic bond. So, their melting point is lesser. Next one, which transition element in the following shows only one oxidation state? Already we discussed the scandium shows only one oxidation state, +3. Which transition element in 3D shows highest oxidation state? What is our 3D series? That is our scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Here, which will shows the highest oxidation state? Middle element. What is the middle element? Manganese. It shows +7. In 3D series, highest oxidation state is given by manganese +7. 86. The highest oxidation state in transition metal compound are achieved in fluorides and oxide. Yes, we studied. Why the higher oxidation state only possible with oxides and fluoride? Because oxide and fluorine are most electronegative element. They make very strong ionic bond. So high electronegativity of fluorine and oxygen, yes, they form weak and no, they form very strong bonding. Okay, more number of unpaired electron variable. No, due to the high electronegativity of fluorine and oxygen, they will try to pull maximum electron from the metal. So metal can show higher oxidation state. Magnetic moment of scandium 3+. What is the equation for magnetic moment? Root of n into n plus 2 Bohr magneton. Scandium, right? Scandium is 21. 21 means what? Argon 18, 4s2, 3d1. Scandium 3+ mean this 2, this 1 gone, only 18. 18 means what? Fully filled. No unpaired electron. No unpaired electron means what? Magnetic moment is 0. Why transition element form complexes? There are mainly 3 reasons why transition element form coordination complexes. Because the metal are smaller in size. Because of smaller in size, they have high charge density. And third one, they provide, they have vacant d orbital. So they comparatively smaller in size. Yes, they have high ionic charge. Because of small size, they have high ionic charge and availability of vacant d orbital. All of these, okay, all of this. What are the properties of interstitial compound? We studied 4 property. Higher melting point than pure metal? Yes. Very hard? Yes. They retain their metallic conductivity? Yes. One more is there actually. They are chemically inert. So all of these are property. 90th question. In acidic medium, yellow chromate. What is chromate dear? CrO4 2 minus, right? CrO4 chromate, CrO4 minus ion is converted into which one? See, acidic, they are asking acidic medium. We already discussed the chromate become dichromate. Chromate is yellow color, right? Chromate is yellow color. Yes, chromate is yellow in color. And when it is converted to CrO4 2 minus, chromate, when it is in acidic medium, it converted to what? Dichromate, right? Chromate is what? Yellow in color. Sorry. Chromate is what? Yellow in color. This is what? Chromate. Chromate, CrO4 2 minus. And dichromate is what? Cr2O7 2 minus. Chromate is yellow in color. In acidic medium, it converted to dichromate. That is what? Orange red in color. Orange red. 91. KMnO4 is preparing from. KMnO4 is preparing from which oral? Manganese dioxide. MnO2, that's called pyrolusite. Pyrolusite ore. Chromite ore is which one dear? FeCr2O4. It's a FeCr2O4. It's a preparation of which one? A dichromate ion. Potassium dichromate. Pyrolusite ore is which one? MnO2, from where we are preparing KMnO4. What is galena? That is an ore of lead, okay, PbS. And the bauxite, you know, aluminium ore, Al2O3. So pyrolusite ore. 92. When KMnO4 heated, what form? Here there is an equation. KMnO4, when you heat it, it becomes three things. K2MnO4, MnO2 along with the oxygen. So KMnO4, when you heat it will give you potassium manganate. What is KMnO4? Potassium permanganate. What is K2MnO4? Potassium manganate. Potassium manganate. Ready? So what happened? KMnO4 heated, it forms what? K2MnO4. How many Mn double bond O bonds are in permanganate? We already discussed the structure of permanganate. What is permanganate? Permanganate is MnO4 minus, right? So we can draw like a double bond O, double bond O, double bond O, O minus. A small hint is there. MnO4 minus, right? Minus 1, right? Minus 1. Minus 1 means there is only one oxygen with a minus 1 charge. There is only one oxygen with a minus 1 charge and single bond. Remaining all the three oxygen will be double bond. What is that? Overall charge is minus 1 mean there will be only one oxygen with a charge minus 1 and it is single bonded oxygen. Rest of all oxygen double bond. So how many Mn double bond O bonds are there? 1, 2, 3. 3 are there. Next. In acidic medium, KMnO4 convert nitrite. NO2 minus is called what? Nitrite converted to what? Nitrate. What is nitrate? NO3 minus. Please note KMnO4 convert which all compound to which one? One is iodide in acidic medium. Okay, I'm saying in acidic medium, I minus converted to I2. Ferrous converted to what? Ferric. Sulfide converted to what? Sulfur. Sulfite converted to what? Sulfate. And oxalate C2O4 2 minus converted to carbon dioxide. And nitrite NO3 minus converted NO2 minus converted to NO3 minus. Nitrite converted to nitrate. Which of the following is the consequence of lanthanide? There are three consequences we studied in lanthanide contraction. One is the 4D and 5D transition series, transition element series shows similar atomic size. Second one, separation of lanthanide from mixture is very difficult. We can predict the basicity from lanthanum to lutetium, basicity decreases. Element of 4D and 5D series have similar size, yes. Separation of lanthanide element from its mixture is very difficult because they have similar size. Can predict the basic nature. See, lanthanum to lutetium to lanthanum, or we said lanthanum to lutetium, it decreases, right? Yes, correct. So all of these are the three consequences of lanthanide contraction. 96. Name a member of the lanthanoid series which is well known to exhibit +4 oxidation state. Here in lanthanide, +4 state is mainly given by cerium. Simple. Cerium atomic number 58. Why? Because lanthanum atomic number is 57. After lanthanum, lanthanides are starting, right? First lanthanide is cerium. Cerium configuration, let me write. Xenon 54, then we have 4f, 5d, 6s. After 54 to 58, 4 more electron, we can fill 2, 1, 1. If they remove all these 4 electron, they are getting stable configuration. So cerium common oxidation state is what? +4. Now, lanthanides react with the oxygen and form. There is a chart given in your textbook. Lanthanum, they mention as lanthanum as the generalization Ln. You know, lanthanum general oxidation state is what? 3+. Oxygen general oxidation state is what? -2. So what is the formula of lanthanum oxide? Ln2O3. That's it. Ln2O3. Then actinide contraction is more. We studied actinide contraction is more than lanthanide contraction because of the very poor shielding effect of 5f orbital. Actinide contraction is more than lanthanide contraction due to the poor shielding effect of 5f orbital in actinoid. Okay, 99, second last question. In dichromate ion, what is the dichromate ion structure? You remember? Cr double bond O minus. Cr double bond O minus, and there is an oxygen. So in dichromate ion, how many CrOCr? There is only one, right? How many CrOCr bond is present? One. Basically, they're asking whether you know the structure or not. Ready? Last question, number 100. In the preparation of K2Cr2O7, how many steps are there in preparation of K2Cr2O7? 3 steps are there. Once again, I am reminding you, K2Cr2O7 is preparing from which ore? Which ore we are preparing here? We are preparing from pyrolusite, sorry, the chromite ore, right? What is chromite ore? FeCr2O4. First chromite ore we will treat with the sodium carbonate with the free supply of oxygen. So the FeCr2O4 become Na2Cr O4. That's called a sodium chromate. Byproduct and all we have to study, okay? Second step, this is the first step. In second step, you know what happened? Sodium chromate, we will react with the acid, which is the acid we are using, H2SO4. Sodium chromate become Na2Cr2O7, sodium dichromate. The sodium dichromate in third step, we will treat with the KCl. So potassium comes, you will get K2Cr2O7. Sodium dichromate become potassium dichromate. So question, in the preparation of K2Cr2O7, chromite ore means this one, converted to sodium chromate. Sodium chromate is this one. By which reaction? By treating with what? Na2CO3 and oxygen. That is option A. So this is our 100 MCQ from the chapter D and F block. I think almost all area we covered. You all make more confidence in your theory concepts, and A to Z line by line we have to read and study, because we have to expect that exam level may changes. So whatever level changes, we have to change our level also, our confidence also, our knowledge also. So please practice it. Wish you all the very best. Thank you.